Firstly, let's discuss about how to get your readings. Please, my dear lovely student, make sure you draw your table very well. You know, when you are drawing your table, you have your burette reading, you have your final burette reading first, then followed by initial, followed by volume of acid use. That's how you arrange them row. Then when it comes to column, you have your rough titration, you have your first titer, second titer, and then your third titer. Then you fill your acid inside the burette, you pipette your base. You fill your acid very well so that you observe what we call lower meniscus. That is 0.00. That will be your initial. Your initial will be 0.00. You can constant it all through. Initial for titer 1, initial for titer 2, initial for titer 3. Make it 0.00. And we have what we call endpoint. What is endpoint? Endpoint is the volume at which the acid has actually completely neutralized the base. You know, when you pipette your base, you put indicator inside your base. Let me assume that you are using methyl orange. When you pipette your base, you put methyl orange inside that base. And then the color of methyl orange is what? The color of methyl orange inside the base will be what? Will be yellow. Then at the end point, the color change to pink. That pink is what we call endpoint. At that point where you have the color change to pink, there is a volume on the burette. You record the volume on the burette and then you repeat the titration for as many as possible. You can make it twice, you can make it 3, you can make it 2 titers, you can make it 3 titers, but ensures that you obtain what we call concordance value. What's the meaning of concordance values? Concordance values are titers in which their difference is plus or minus 0.2 centimeter cube. I repeat that again. Concordance values are titers in which their difference is plus or minus 0.2. So once you are able to obtain concordance values, by the time you want to calculate the average volume of acid use, you can just make use of those two concordance values. Let's assume that your titer, the first titer is 22.20. The second titer is also 22.30. So you can pick the two and divide by 2. And that's how to calculate average volume of acid use. So if you are using 3 titers, that means that if your first titer is 22.2, the next titer is 22.3, the third titer is 22.4. So you can pick the 3 titers because the differences between them is not more than 0.2. And if you pick the 3 like that, you divide by 3. By doing so, you have calculated the average volume of acid use. Now let's move on to formulas that we use to calculate quantities in chemistry practical. Definitely, the question will ask you to calculate average volume of acid use, which I've explained right now. And then the question will definitely ask you to calculate concentration in mole per dm cube, concentration in gram per dm cube, and then the question can even ask you to calculate the molar mass, and the question can also ask you to calculate percentage purity and percentage impurities. If the question is asking you to calculate concentration in mole per dm cube, what are the formulas that you can use to calculate concentration in mole per dm cube? What are the formulas you can use to calculate concentration in mole per dm cube? We have 2 formulas that you can use to calculate concentration in mole per dm cube. Firstly, that concentration in mole per dm cube, we can call it a molarity. And the formula to calculate it is mass concentration over molar mass. How do we identify mass concentration? The unit for mass concentration is gram per dm cube. The unit of mass concentration is what? Is gram per dm cube. The unit for molar mass is gram per mole. Please, I want to beg you, my student, those of you listening to me right now, WAEC and NECO don't joke with units. Please, if you, let's assume that the unit of that quantity you are calculating just slip your mind, or you forgot, or you forget anyhow, please don't put wrong unit. Ensure that you put correct unit to the quantity you are calculating. So I repeat, molarity, which we call mole per dm cube, or concentration of acid or concentration of base in mole per dm cube, we call it molarity. And the formula to calculate that is mass concentration, which is in gram per dm cube, divided by molar mass, which is in gram per mole. So at times this formula is possible is not working, provided that you can't identify your mass concentration in gram per dm cube of the acid, or you cannot calculate the molar mass of the acid, provided that let's say the molar mass of the acid is not the correct formula of the acid is not given. Let's say the acid is HX, and then that X, it just represent a particular, maybe anions. The whole S represent a particular anions, and then you are not given the correct formula of the acid. Definitely you cannot calculate molar mass. And once you cannot calculate molar mass, that means that you cannot use molarity is equal to mass concentration over molar mass. So whenever molarity is equal to mass concentration over molar mass is not working, then you can use another formula that we call Savannah. What do I call it? Savannah. Again, Savannah. And what's the formula? CAVA over CBVB is equal to NA over NB. Ca is the concentration in mole per dm cube. Cb is the concentration in mole per dm cube of acid. Ca is that for acid, and Cb is that for base. Va is the volume of acid use. Va is the volume of acid, which is your titer value, and Vb is the volume of base. Most of the time it's always 25.0 centimeter cube. And Na over Nb, I say is equal to Na over Nb. What is Na? Na is what? Is the mole ratio of the acid, and Nb is the mole ratio of the base. If you are just joining us, you are listening to Mr. Oloruntoba Kayode Segun on Aku Radio 88.5 FM, and I've been discussing about what you need to know about chemistry practical, NECO chemistry practical. I know making subject of the formula now is not something difficult to do, because you have done that even in SS1 and in Premi 5. So let me give you another formula that you can use if you have to calculate percentage purity. So percentage purity, the formula is mass of pure over mass of impure multiplied by 100 over 1. I repeat, percentage purity is equal to mass of pure over mass of impure multiplied by 100 over 1. Whatever mass you got through formula means that is the mass of pure. Mass of impure will be given in the question. The question will give you mass of impure. Please take note of that. If the question give you mass of impure, don't use mass of impure to calculate anything. You can only make use of mass of impure to calculate either percentage purity or percentage impurities.